Role of novel Pdms panels in monitoring partial discharges in GIs. Abstract. This paper presents the functionality and role of Pdms panels for the monitoring of partial discharges in the GIs, which is done in order to detect the faults on gas-insulated switchgears earlier so that the equipment is prevented from being damaged. The panel components and functioning of each component is clearly mentioned. The interconnection between the panels and the main equipments used were also discussed in detail. A specially designed Pdms panel serves the purpose of easy communication, monitoring and recording the partial discharges taking place in GIs on time-to-time basis through specialized software. The communication in between the Pdms panels and equipments is done through fiber optic cables for fast and accurate readings. Keywords: PD, partial discharge, UHF sensors, and GIs, gas-insulated switchgears, EHV, HV, Pdms, fiber optics, LAN, and SF6. Introduction. GI substations are in huge demand in the modern world scenario where there is lack of space availability for the big constructions. The typical transmission 400/132/33 kV or 380/110/13.8 kV substations utilizes vast area if it is outdoor substation. The introduction of GI substations has a tremendous variation in the occupancy of land when compared to outdoor substations. Now the protection of these transmission substations plays a vital role for the power system network. Partial discharges occurring in these substation heavy equipments like GIs, power transformers etc., which contributes to the major part leading to the damages. So to secure and safeguard these heavy equipments against all blackouts and faults is the main criteria. UHF sensors are utilized for the detection of these PD pulses, and monitoring is done by the specially designed Pdms, partial discharge monitoring system, panels. 2. Partial discharges in GIs. Partial discharges in gas-insulated switchgears occur at high pressure of SF6 gas with very small gaps and have rapid breakdown times of sub-nanoseconds. PD pulses with fast rising waves have frequencies above 1 GHz, which causes to excite switchgear chambers to various modes of resonance with ultra-high frequencies. The resonance persists for about microseconds at least as the chambers acts as low-loss microwave cavities. The signals have very low voltage of around millivolts are amplified, displayed, which makes the defect to detect easily. Gas-insulated switchgears in general for transmission substations follow the double-bus single breaker scheme for 110 kV or 132 kV and 1.5 breaker scheme for 380 kV or 400 kV substations. Typical GIs photo for 380 kV GIs is as below. 3. Pdms partial discharge monitoring system. The Pdms system plays a crucial role for continuous monitoring the occurrence of partial discharges in the gas-insulated switchgears and to communicate, updates the same in the HMI as well as the remote control center. It has main 3 panels known as OU optical unit, DC distribution cabinet, CC control cabinet. The general arrangement for Pdms system can be represented as below. 4. Optical unit, OU. For the amplification and UHF signal detection, optical unit has 6 individual front-end signal modules. To protect from transients of high voltage, diode protection is available. It has facility for channel self-test periodically to test the working condition of optical unit. By the process of filtering, the narrow band noise is filtered out. The obtained signal after detecting and filtering is digitized and processed to get the data from each channel. This process checks the data stream for any partial discharge activity and records elements required for viewing through partial discharge monitoring software on PC system. The pulse is processed by detection and data acquisition system. The obtained result of ultra-high frequency channel is sent to PC system and fault recorder system. The control signals from PC system are transmitted through Ethernet cables to optical unit. V distribution cabinet DC. Distribution cabinet acts like communication between the control unit and optical unit. All Ethernet connections are routed by distribution cabinet and transfer them to control cabinet by using a high-speed fiber link. The distribution cabinet quantity depends on the size and complexity of partial discharge monitoring system. The main components of distribution cabinet are a Ethernet switch. The Ethernet switches acts as interface between OCU data to RCC. Ethernet communications between the OCU and RDC can be fiber or copper depending on system configuration. All connections between RDC and RCC are through fiber. B. Fiber termination box housing for fiber cables terminations from RCC. C. Synchronization driver unit. Sync driver unit receives timing and reset data from a synchronization interface unit fitted within RCC. This signal is generated from PCU system during normal operation and external sources during testing. The RDC sync driver unit converts incoming data to sync signal to drive OCU. The output is connected to OCU mains cable sync line within RDC. D. Heater system. Heater system is installed to prevent the buildup of humidity which can damage electronic systems within it. This system incorporates self-regulating heater that is controlled by hygrostat. E. Circuit breaker for safety protection system. The different circuit breakers serves different purposes like to isolate the I input power from control cabinet, allows isolation of power to the circuits in distribution cabinet. 2. OU power, OU heater. 6. Control cabinet CC. The control cabinet is the main central data, control, and power hub of partial discharge monitoring system. For the final processing and recording purpose, all the data from optical units are transmitted to monitoring server within control cabinet. The integration for the control and fault detection is done within monitoring system. Control cabinet has direct interface between the monitoring system, SAS, or SCADA network and external LAN. The main components of control cabinet are a power control unit. This interfaces the system server to the inputs like partial discharge alarm, loss of AC alarm, etc. The server watchdog is available for monitoring of the system server software. Pulses received from the server are detected and used to reset counters/timers in the PCU firmware. If no pulses are received in a time defined by the firmware, the PCU will signal a fault by setting an alarm and will reset DC supply to server. B. Server. The server controls the monitoring system displays and stores the system data. It links to PCU via serial cable for accurate phase timing from the VT inputs and alarm data. Data from OCU is phase resolved in software and displayed in correct phase and timing. This data is then collected during operation and stored as historical information from the system. It also contains dual LAN interface, LAN1 for the PCU local network to OCU and LAN2 for is used for remote access to headquarters PC system. Cgps System. A global positioning system, interface module is installed in control cabinet which translates the signal of GPS system to a time code signal via serial link to server. The time signal is supplied from GPS module. Data is received by GPS module via an external antenna. The antenna cable to cabinet equipment is protected by surge voltage protector. D. Ethernet switch. The Ethernet switches acts as network interface between the distribution cabinet and server. E. Fiber termination box. All the fiber cable terminations are done here. F. UPS. This provides the filtered AC supply to monitoring system with battery backup and provides the ability for the safe shutdown of server during the loss of AC. G. Hot swap unit. This permits the removal of UPS without loss of power to the monitoring system. The typical control cabinet is as below. 7. Conclusion. The monitoring of partial discharges is done perfectly with the help of above-mentioned system using the optical units, control cabinets, distribution cabinets. This accuracy of monitoring the PD activities is essential for the early detection and prevention of the faults on gas-insulated switchgears, by which the equipment is also saved from being damaged, which might result in huge loss. By using the advanced communication and control system like substation automation system, the monitoring is done easily from the far end remote control centers. Hence the GIS is protected from damages and blackouts, and thus the stability of power system network is maintained.